So now we're going to have the first speaker. He's not AWS, but pretty close. He's from Amazon.com. He show you something on the bright side, how things work. So and also talk about AppSync, how it works. So let's welcome him. You probably want to set it up. And while he's setting up, I say, all of you are the speakers. So you can be the next person sitting there. And if you just want to do some speech, can be as short as 5 minutes, can be as long as maybe like 30 minutes, maybe 35 minutes. Talk to me, Franklin, or other organizer. So that way you will be as smart as this gentleman. Perfect. All right.
Yeah, hi everyone. Thanks for this meetup, Sami, and giving me this opportunity. Myself, Akhilesh Bulam, I'm an SD2 at Amazon Kindle. So I work on large-scale systems, mainly focused on real-time data synchronization. Today, I'll talk about how cross-device syncing architectures can be built with AWS AppSync. In today's world, it's a very important use case where you end up syncing data across multiple devices, whether you take note-taking apps or collaboration apps or any messaging apps. It's quite important that data must reach from one customer, from one producer to other consumer. That way, data is consistent across devices. So the focus here is not just about real-time updates, but it's more about building such systems without managing complex WebSocket structures or infrastructures. So I'll basically walk through the architecture, how it works under the hood, and then show a light. So why is real-time cross-device syncing pretty much hard to achieve? Because there are multiple aspects to it. For example, multiple devices. In today's world, people end up buying lots of devices, like they'll have iPhone, iPad, desktop. So the data has to be consistent across these devices, right? And the data cannot be corrupted as well. And users expect instant propagation as well. Like every millisecond is quite important. Any increase in this delay, like you will lose the customers. And the third thing is network unreliability. You can always expect network to drop, due to which clients try to drop and try to reconnect and sometimes miss event. That makes things to go in the wrong direction and corrupt the data. And the other thing is conflicts. Since there are multiple devices, you expect few concurrent things to happen at the same time. So that has to be handled in a proper manner. And the other thing is the infrastructure complexity. So you have to deal with lots of backend infrastructure in order to achieve this. So let's look at how traditional custom architecture looks like. Before managed services like AWS AppSync, people used to rely on some of the legacy way of dealing with real-time data synchronization. On the outer side, like they used to have clients connect persistent storage. That's a standard pattern. And in the middle layer, they usually have a separate server to manage all the WebSocket connections and its sticky state. And there's a message broker which tries to handle real-time updates. For example, let's take Kafka. So these are the systems like they need to handle. It may not be hard to build these systems. The real hardest problem is how to manage them, because as your user base keep growing, you have to deal with millions of open connections and sticky sessions, and you have to have handle the load balances as well, and you end up like reliability issues with respect to message guarantee or retries or failure handling. And the biggest part is the operational overhead. Since you deal with multiple services, you end up getting lots of operational tickets, or you have to do regular patching in order to keep your services in good state, and you'll have to have regular on-call duties for your engineers. So that's quite large when you try to manage each and everything under the hood. So how AppSync is really useful here. So what exactly is AWS AppSync? It's a fully managed GraphQL service which is used to handle real-time data updates. So it basically has built-in subscription capability wherein it manages all the WebSocket connections under the hood. The clients don't really have to worry about all the open connections or the WebSocket management. It does have native integration with data sources like DynamoDB or Lambda as such, and it does have built-in security with respect to AWS IAM, AWS Cognito API keys. So clients don't really have to worry about building all this stuff. All these are interconnected within AWS environment. So instead of building infrastructure, you focus on defining your data model and how clients interact with it. Now let's look at high-level AppSync architecture. So mainly there are clients, it may be web or mobile, that tries to send some data. In GraphQL world, it's called a mutation. It's nothing but change. We'll come to that. And there's an AppSync GraphQL API in the backend that takes these mutations or updates from devices and forwards or delegates to underlying resolvers. It could be Lambda, DynamoDB. And there's subscription part that lies within AppSync that always watches for real-time changes within your data. So the key advantage here is like you don't need to build or manage WebSocket servers or message brokers or scaling infrastructure. AppSync will take care of it. So going into some details, what is GraphQL? So GraphQL is essentially a query language for your APIs. It does have like three core operations like mutations, query, and subscription. Mutations are nothing but any update that you make. It could be a create or update or delete. Query is nothing but you need to fetch the data from the servers. And the third and most powerful capability of GraphQL is the subscription, which watches for data changes in real life. So quickly comparing with REST APIs, in REST world we typically have multiple endpoints, and clients request multiple endpoints and often fetch more or less data. But within GraphQL world, we only have single endpoint that can aggregate data from multiple data sources, and clients have more control over the data rather than server controlling it. That's what happens in REST, where server actually controls what data to send to the clients. But in GraphQL, it's the client that controls it. So going into GraphQL schema, so what's GraphQL schema? It's mainly, it can mainly define all your data types within our application and relationships between the data types, like how your data types has to connect with another data type, whether it has to be a one-on-one or many-to-one or one-to-many. And it specifies three operations that we just discussed: queries, mutations, and subscriptions. And mainly it acts as a contract between client and server. That way client knows how to talk to the server. And it does have a powerful feature called directive support for defining or embedding behavior within the schema itself. For example, we have like subscription directives or authorization directives that are very powerful in defining how subscription has to work or how authorization has to work within AppSync. So this is a example GraphQL schema. As you can see, we have a simple message type that includes a unique ID and an author and a body of the message. And there are three operations that can execute on top of this data, like query, mutation, or subscription. If you closely look at the subscription part, there is a directive called AWS subscribe, which actually connects the subscription and the mutation. That way AppSync will know that this particular client is interested in some of the mutation changes from another client. That's how AppSync knows, okay, I need to build a connection between the subscription and this mutation. So with just this schema, we have defined both API and real-time behavior without really building any custom infrastructure as such. So under the hood, how AppSync works. So there are resolvers that map GraphQL operations to data sources like DynamoDB or resolvers. So they try to transform request and response before returning to the client. Within resolvers, there are two types of resolvers: unit resolvers and pipeline resolvers. Unit resolvers, like, they try to operate on single data source, whereas pipeline resolvers, they try to operate on multiple data sources. So in a nutshell, while schema defines what should happen, the resolvers define how it actually happens. Let's discuss one of the data sources called DynamoDB. It's a fully managed serverless NoSQL database that provides low latency and high scalable storage. Within AppSync world, resolvers can directly interact with DynamoDB, so you don't really have to worry about building a separate API that can talk to DynamoDB. Everything is interconnected between AppSync and the DynamoDB. So when a client sends a mutation or a data change, AppSync invokes the corresponding resolver, which directly performs operations like put item, get item that are specific to DynamoDB. So in our demo that I'm gonna show, we will use DynamoDB as a simple use case where all the messages will be stored there and retrieved from DynamoDB. So now that we have seen all the building blocks, let's put everything together and see how everything works. On the left side, we have like multiple clients. User one is using their own device. User two is using their own device. Let's say whenever user one sends a message, it does create a GraphQL mutation, which is an update, and received by AWS AppSync GraphQL API. There's some kind of mutation processing that happens within AppSync, and it does talk to the associated resolver. Here it's the DynamoDB, which acts as a data source to store the data. So once the resolver takes care of writing the data to the DynamoDB, it returns a response back to the AppSync saying that it was successful. That way it knows a mutation was successful. Subsequently, there's an internal signal that AppSync tries to generate saying that a mutation has been updated. While on the user 2 side, if they are really interested in updates from user 1, what it can do is it can call the GraphQL subscription operation from the GraphQL schema contract. That way, subscription management within the AppSync receives that request and does create a connection between the user 1 and user 2 in a subscription map. So whenever a real-time update happens from user 1, after the mutation is processed, it does check the subscription map to see whether any active clients are subscribed to this data. That way it will notify user 2 over WebSocket connection in a push notification manner. So let's look at a live demo wherein I can show you how these real-time updates happen between two clients. Yeah, so we have like two clients. It's a simple chat application wherein an author can send a message. So let's see how this is all built with AWS AppSync. So I do have a Spring Boot app that's running on my laptop. It's just a simple Spring Boot app which hosts the index.html UI page. This page What it does is it directly connects with AWS AppSync using API key, and for any GraphQL mutation
Can
or
you make
query.
the phone bigger?
Oh, yeah. Yeah. So for any GraphQL mutation or subscription or query operation, it directly talks to the AWS AppSync. So whenever a client tries to send a message or tries to generate a mutation, AWS AppSync under the hood receives it and tries to talk to the resolver, which is DynamoDB in this case. So let's look at my demo app within the AWS AppSync, how it looks like. So this is the home page for AWS AppSync, and this is the demo app that I created. As you can see on the left-hand side, these are some of the capabilities that AWS AppSync provides, like schema. So this is the page where you define your schema, like how do you want to really envision your data. As we just looked at the schema, example schema, this is the same schema that I'm using, where the data type is a simple message body, and we define 3 operations: mutation, subscription, and query. And on the right hand side, there are associated resolvers. Basically, a resolver connects a field or an operation to a data source. Basically, it will tell what really AppSync has to do whenever something happens, like a mutation or a query. As you can see, whenever a mutation or query happens, I'm telling AppSync to talk to this DynamoDB table. So I already have a DynamoDB table already up and running within the DynamoDB layer. It's a simple table with 3 fields. Yeah, right now the data is empty, but this is where you can kind of define and attach your data source with AWS AppSync. You can attach resolvers for each field as well. That means whenever something change happens for that particular field, you can have your own resolvers, maybe like a Lambda, and you want to run some custom logic when this happens. You can do that using these options. For subscription as well, you can attach a custom resolver. That way you can intercept whenever a subscription request comes from one client, and if you want to run some custom logic there. But right now for the demo app, for simplicity purpose, I'm just relying on the inbuilt subscription logic that AWS AppSync provides. So that everything is abstracted and AWS AppSync takes care of all the subscriptions and maintenance. Now let's look at how things work between the 2 clients. So this is my Google Chrome client, the one on the left side, and the right one is the Safari. So let's create some authors in the system, that way we'll know what's going on. Let's have author Apple. And from Safari, let's have author Banana. So as you can see, the live feed for each of the client is never updated because these clients are never subscribed. That's why data is not flown in real time. Let's say Apple on Google Chrome, if it wants to hear or listen to data from Banana, what it can do is it can just go and subscribe to Banana. So this one says subscribe to Banana. Now whenever Banana generates or creates any new message, the live feed on the Apple will update. Let's try to send a message from Banana, and you try to monitor the live feed on the left hand side, that is for Apple. See, as you can see, the live feed is quickly updated in real time. So that's how subscriptions work. Once a client is subscribed, that client maintains a persistent WebSocket connection with AppSync. That way AppSync can connect with client whenever it needs. Yeah, so going back, there was a demo. Let's look at some of the other components within AWS AppSync, mainly the authentication and authorization. So AWS AppSync does provide authentication support in form of Amazon Cognito user pools or IAM roles or field level authorization or encrypted connection. With Amazon Cognito user pools, you can maintain all your user base inside those user pools and try to try to authorize them at runtime. For machine-to-machine access, you can use IAM roles. And for field level authorization, you can use directives like AWS auth, which controls access to specific user for a specific field. These are called the fine-grained access. And encrypted connections, so all WebSocket and HTTP connections to AppSync are TLS encrypted, so you don't really have to worry and no additional configuration is needed. And coming to the scaling within AWS AppSync, clients doesn't really have to worry about anything here. AWS AppSync takes care of everything. No WebSocket servers, all the connection management, sticky sessions, everything is managed by AWS AppSync. No load balancers as such, and no manual scaling. AWS AppSync can increase its capacity based on the traffic, and you always have a good paper request model wherein you'll only be billed for the things that are used. You don't be billed for idle infrastructures. So these are some of the best practices. For example, always try to use fine-grained subscription filters. That way you can eliminate noise. Clients don't really have to worry that they're always notified all the unrelevant data. So that can be done on the client side or on the server side. Mostly it's done on the server side so that server will have all the context to know what data has to be published or what not. Try to keep your payloads very small. So whenever you notify other devices, try to notify with a delta rather than sending the full payload. That way your network is in a good state and it's not bombarded. And try to index your DynamoDB properly. That way you eliminate full scans whenever you work with subscription logics. And you do monitor AppSync metrics in CloudWatch. It's auto-connected between AppSync and the CloudWatch. So look for bad requests, 400 errors, internal server errors like 500s, latency, and other metrics before you go into production. So what are the key takeaways from here? So real-time sync is pretty hard to build from scratch. Like I said, connection management, scaling, ordering, and read-write logic, all you have to take care of. And AppSync eliminates the WebSocket layer. AWS completely manages persistent connections, fanning out to multiple clients, and scaling. You mainly focus on schema design and your business requirements. And GraphQL subscription, like they try to simplify push so that whenever a mutation happens, you don't really have to worry about configuring a separate pub subsystems like Kafka. And DynamoDB plus serverless will give you a good reliable foundation so that updates are sent in real time with low latency. Yeah, that's pretty much it.
A couple of quick questions. So if in your nice little demo that you put together there, I appreciate the two completely separate browsers so you know they're in their own sandboxes. Once you put up a couple of messages, then you had the one user subscribe to the other one, and then it got the message, the next message. Are there built-in tools for doing things like delivering all previous messages to that user?
No. In that case, you have to poll separately. Subscriptions only work for that specific update in real time. So it doesn't really care about what were the previous messages. So you have to build your client in such a way that it has to poll the previous messages.
Okay, so you put that in your resolver. You'd say, you take a quick check. Has this guy been signed up before, and what do you want to do with it?
Right.
Okay, my next question is probably the same answer because you put your custom code inside of your resolvers. If you have messages with different levels of authorization, some are for certain people, some are for everybody, then that would be a IAM check in the resolver?
Yes, like I said, authorizations within AppSync goes through cognito pools or IAM roles. So whenever you define the schema for your data type, you does make use of those inbuilt directives, like I was showing AWS auth. That way, AWS AppSync will know who is the right client where I can send this notification to, whether they are authorized or not. Authorization is always available within AppSync, and using those directives makes it really easy.
Right, thank you.
Yeah.
So the WebSockets, or sort of the security you have is through the AppSync, GraphQL. What are the trade-offs, or can you speak to the difference of that versus the AppSync events?
AppSync with events versus?
The GraphQL.
GraphQL itself is a core foundation concept within AppSync, correct? I'm sorry, I didn't get your question properly.
Well, okay, so my understanding is that the client was subscribing to the GraphQL endpoint, essentially was getting the notifications from the mutations with that.
Correct.
And there's a separate part to AppSync called
AppSync and GraphQL one and same thing. It's a managed GraphQL service.
Right.
So AppSync under the hood makes use of GraphQL specifications to do this.
Okay, but my understanding from you're using the AppSync events, you don't have to deal with any of the GraphQL stuff.
Right. So AWS, you mean the AppSync event API?
I don't know if it's officially labeled.
Yeah, it's an abstraction layer. Like we can make use of it as well, but this deals with the core concepts. You can always make use of AWS app events. Yes.
But yeah, it's not app events, it's AppSync events.
Right, AppSync events. Any other questions? Yep. Thank you.
All right, thank you. So now, your time saying with PagerDuty. First of all, thank you, PagerDuty. Thank you. First of all, thank you, PagerDuty. I know some of you scan it and you do not have the patience, so they say that, Sammy, distribute some swag. Just ask you guys to scan the code and do something. You know the drill. But before that, I know that once I give you the Lego, everyone want them. You guys probably disappear. So let's welcome the second speaker. We're going to show you, we